Myself, Dr. Poonam Rajesh Advani, Associate Professor, Pharmaceutical Chemistry at Mumbai Education Trust Institute of Pharmacy. The topic for today is diuretics. The learning outcomes from today's sessions include the learners will be able to understand the effects of diuretics, identify the different sites of action of diuretics, and explain the mechanism of action of site 1 diuretics. What are diuretics? Diuretics increase the rate of urine formation by increased excretion of electrolytes and water. Glucose or amino acid reabsorption remains unaffected. Diuretics are used in the treatment of edematous conditions as well as the management of hypertension. The primary target organ for the diuretics are the kidneys. Anatomy of the nephron. There are 4 different sites at which the diuretics act on the nephron. The first site is the proximal convoluted tubule, which is also called as site 1. This is the site of action of the carbonic anhydrase inhibitors. 65 to 70% of sodium reabsorption happens at site 1. Then we have site 2, which is the site of action for the loop diuretics. 25% of sodium reabsorption happens at site 2. Moving ahead to the distal convoluted tubule, which is site 3. This is the place where the thiazides and the thiazide-like diuretics act. And finally, we have the cortical collecting tubule, which is site 4 and the site of action for the potassium-sparing diuretics and involves the reabsorption of 1 to 2% of sodium. Thus, we see that we have 4 different sites which lead to the reabsorption of sodium. The diuretics are classified as osmotic diuretics, those that work on the principle of osmosis. Those which inhibit the action at site 1 are known as the carbonic anhydrase inhibitors. Those which inhibit the action at site 2 are known as the high ceiling diuretics or the loop diuretics. The site 3 diuretics are known as thiazide and thiazide-like diuretics. And finally, we have the site 4 diuretics that inhibit the reabsorption of sodium at site 4 and they are known as potassium-sparing diuretics. Site 1, the convoluted and straight portions of the proximal tubule. Site 1 is responsible for the reabsorption of 65% of sodium, chloride, calcium and water, 80 to 90% of bicarbonate, phosphate and urate, and almost 100% of glucose, amino acids and low molecular weight proteins. There are 3 pathways for sodium reabsorption at site 1. The first pathway involves carbonic anhydrase. Carbonic anhydrase is responsible for the reabsorption of 20 to 25% of the filtered load of sodium. This sodium is exchanged with a proton at site 1 under the influence of carbonic anhydrase. Also, 80 to 90% of the reabsorption of bicarbonate happens under the influence of carbonic anhydrase. The second pathway is wherein sodium is co-transported with glucose, amino acids or phosphate. And then we have the third pathway where both sodium and chloride are reabsorbed together. Let's look at the action of carbonic anhydrase. This is the proximal convoluted tubule. This is the lumen and this is the interstitial space. Hence, this side is known as the luminal membrane and this is known as the antiluminal membrane. In the lumen, we have a variety of ions. These are the sodium ions. Along with sodium ions, we also have the bicarbonate and the proton ions. This bicarbonate and proton under the influence of carbonic anhydrase get converted to carbonic acid. Carbonic acid being unstable gets converted to water and carbon dioxide which very easily diffuse inside the tubule and thus we have carbon dioxide and water. Inside the tubule we again have carbonic anhydrase and this carbonic anhydrase converts the carbon dioxide and water back to carbonic acid. The carbonic acid further breaks down to give H plus and HCO3 minus. It is this H plus which is exchanged for sodium. So we can clearly see that now we have a sodium ion which has come inside the proximal tubule. Now on the antiluminal side, now we have this sodium potassium ATPase. The sodium potassium ATPase actively transports the sodium from the tubule into the interstitial space. This process requires ATP and thus this is known as the sodium potassium ATPase pump, which is responsible for causing the reabsorption of sodium. Reflection spot. Please think about what will be the effect of inhibition of carbonic anhydrase. Take a pause and write down your answer. Carbonic anhydrase inhibitors are the site 1 diuretics. They inhibit carbonic anhydrase and thus stop the exchange of Na plus and H plus, thus inhibiting the reabsorption of 20 to 25% of sodium, leading to increased sodium concentration in the luminal fluid and finally leading to increased excretion of sodium in the urine. This is nothing but increased excretion of electrolyte as well as water in the urine and thus diuresis has been achieved. Acetazolamide is an example of a site 1 diuretic. This is the structure of acetazolamide. The parent is acetamide, hence we write it at the end. This is the thiadiazole moiety. The numbering is as shown. So at the 5th position, the substituent is sulfomoil. So we write 5 sulfomoil, 1, 3, 4, thiadiazole, 2YL. It is a second position which is attached and hence it is 2YL and the parent is acetamide. Thank you for your kind attention.